A good day to all. Gents, I want us to now shift focus to the exponential function. So now I want us to maybe just go through the general exponential form first, which is also referred to as the standard form. So now, gents, the standard form will read as y equals a times b to the power x plus p plus q. So now a in itself would be more with regards to the location of the graph itself. So now if a is greater than 0, so that would be a positive a. So that's the a that we are referring to there. If a is positive, so that's greater than 0, then the graph lies above the horizontal asymptote. So now remember that an asymptote is just a line that the graph itself cannot touch. So now a being less than 0, so that would be a negative a. You can then have the graph itself lying below the horizontal asymptote. So that would be the effect of a. So now for b, so now this also just only applies if a is greater than 0. So that would be for b over here. So now if b is greater than 1, then you have an increasing graph or an increasing function. So now remember that for a function to be increasing, it has to have a positive gradient. So the gradient has to be greater than 0. And if b is between 0 and 1, then you have a decreasing function. So that would be a negative gradient over there. So the gradient would be negative. So that in itself would be the effects of a as well as b. So now p in this case would be the horizontal shift. So you are essentially shifting the graph either to the left or to the right. So if you are shifting the graph to the left, so that would be the left over there, it means that p has to be greater than 0. So that would be a positive p. If you are shifting the graph to the right, then p has to be less than 0. So that would be a negative p. The q in this case would be the vertical shift. So that would be shifting the graph either upwards or downwards. If the graph is being shifted upward, then q has to be greater than 0. So that would be a positive q. If the graph is being shifted downward, then q has to be less than 0. So that would be a negative q. Also, q in itself is the horizontal asymptote. So what that means is the graph itself can never equal q. So y can never be equal to q. Therefore, the horizontal asymptote, which is the line that the graph itself can never touch, would equal y equals q. So that in itself is the horizontal asymptote. So now remember that the function itself can never equal q because this portion over here can never equal 0. So there's no possible x value that you can choose that would allow this first term to equal 0. Hence, y can never be equal to q, and also y would essentially just be the horizontal asymptote. So now, gents, I've prepared a few questions that I want us to go through. So that would be on this page over here. So now the questions read, given f of x equals negative, bracket, 1 divided by 2 to the power x plus 2. So that would be the exponential function that we have been given. So now the questions 1.1 wants us to write down an equation of the asymptote of f of x. So now again, the asymptote would be equal to q. So we can then just have the, so I'm going to just write this with the red. So that's 1.1 over there. So that would be y equals to 2. So the 2 over here would actually just be the q. So the equation of the asymptote of f of x would just be y equals 2. So now 1.2 wants us to determine the coordinates of the y-intercept of f of x. So I'm going to just move on to the next page for us to be able to do so. So that would be the y-intercept. So that's 1.2. For the y-intercept, we know that we have to let x to equal 0. If we do so, so that would be f of x over there. So we'll have negative 1 divided by 2 to the power 0 plus 2. This in itself will still just be negative, and then the inside would just be 1. So remember, anything to the power 0 would just be 1. And this would then be just negative 1 plus 2, which would equal 1. So the y-intercept will read as 0 is to positive 1. So now that in itself would be the y-intercept. To find the x-intercept, we have to let the y to equal 0. So that would be 1.3 over there. So that would be x-intercept. And we would need to let y to equal 0. So now this in itself will give us 0 equals negative 1 divided by 2 to the power x plus 2. So now the inside here, so we can actually move the half to the other side. So this would just give us a that over there, which would equal 2. This in itself would actually just be 2 to the power negative 1. So we essentially just have a 2 to the negative x, which equals 2. So remember that the 2 is to the power 1. Since we have the same basis, we can ignore the basis and just write the exponents. So this would be negative x, which equals 1. Therefore, x would equal negative 1. So the coordinates of the x-intercept would read as negative 1 is to 0. So now that in itself would be the coordinates of the x-intercept. So now, gents, that's what I wanted to share with you guys today. Please do have a look and attempt the questions that do follow. A very good day to all.